Good afternoon, algebra students. Today we're going to be covering the Unit 1 review. It's in the back of the workbook. So go ahead, when you're ready for the review, go ahead and turn to the back of the workbook and we'll get started on that. Now keep in mind, you should have already finished the rest of the packet up to this point. And then just, if you haven't done that already, go ahead and do that, then come back and watch this video. Also want to emphasize that everything I write, you should write, as well as everything I tell you to write, you should write. If you write everything I write plus everything I say, you'll do very well. All right. Well, with that in mind, let's go ahead and get started. I'm going to share my screen here and go ahead and turn to the first page of the review, which I believe, let's see what page it starts on, page 63 of your workbook. All right. Fill in the blanks to make the following 6 statements true. Let me go ahead and get my pencil here. Okay, 60,000 is blank times greater than 6,000. So 60,000 is 10 times greater. So notice this has one extra zero than this, so that's 10 times greater. How many extra zeros do we see from 60,000 to 600,000? Or sorry, 60,000 to just 600. Well, that's 2 zeros more, right? So that's 100 times greater. And you could always check. If you do 6,000 times 10, you should get 60,000. 600 times 100 should get 60,000. All right, go ahead and see if you can do this one on your own. 2.0 is blank times greater than 0.2. So notice, same idea, is how many decimals. So if I go right here, this first number, 2.0. If I move the decimal over once, that's 0.2, right? That's the same as this. So when you move the decimal just once, this one is 10 times greater than that, all right? 2 is 10 times bigger than 0.2. 2 is 100 times greater than 0.02, because notice if I take 2.0 and I move the decimal, I'd have to move it twice to get 0.02, right? Which is what this is. So since I moved the decimal twice, that's times 100. And of course, you could always check. If I do 0.02 times 100, you should get 2 as your answer. See if you could do this last one on your own. Okay. Question 2. Andrea wanted to calculate 5% of 300. So she multiplied 300 by 0.5. Okay. Explain in your own words why this equation will not produce the correct answer and what Andrea should have done to get the correct answer. You must also demonstrate the second strategy to calculate 5% of 300 using your knowledge of how quickly find 10% of a number. Okay, well, she tried to do 5% of 300. Now, her problem was she changed 5% to 0.5. This is wrong because 5% does not equal 0.5. These are not equal, okay? To change a percent to a decimal, what you do is you move that percentage over twice. So actually 5%, if you move that percentage twice and turn to a decimal, that actually equals 0.05. So notice that 0.05, that is equal to 5%. Okay, so what we would want to say, and I'm not going to write this, but you need to write something like this in explanation. Andrea moved the decimal just one place when she should have moved the decimal 2 places. Okay. Now, if she were to correctly do it with 2 places, that would be 0.05 times 300. So this should correctly give you 5%. All right. Now, if you multiply that, that gives you 15. So this is the correct way to find 5% of 300. Yeah, so when we're doing a percentage of a number, it's very easy. change the percentage to a decimal by moving it over twice. See? Of means you're going to multiply. So 5% of 300, multiply that. That gives you 15. All right, so 5% of 300 is 15. Now it says also demonstrate a second strategy to calculate 5%. So the second strategy is how to quickly find 10%. So to quickly find 10% of a number, so 10% of 300, all you have to do, if it has zeros on it, to find 10% of it, you just cut off one of the zeros. So 10% of 300 is 30. Okay, so therefore, 5% of 300. So if we can easily find 10% just by cutting off a zero, then you'll be able to easily find 5% as well. Because if 10% is 30, 5% will be half of that amount, right? 5% is half of 10%. So 10% of 30, 10% of 300 is 30. So 5% of 300 will be 15, right? It's half as much because this is half as much. By that same logic, you could easily find 20% of 300. It would be double whatever the 10% is, right? Okay, so you'd want to explain that in words as well. So 10%, in order to find 10%, we just cut off one zero. You're going to want to explain that. And 5% will be half of that. Okay, so you just want to explain that in a sentence or two as well. Okay. Now we have some integer stuff. Let's start working these out. I'll work out some of them with you, but I want to look at some of the rules, especially the rules when it comes to multiplying. So when it comes to, so these are multiplying rules. Multiplying rules. If you do a negative times a positive, that'll give you always a negative. A negative times a negative is always a positive. Okay. Now, the adding and subtracting rules are quite a bit different, but the multiplication, and these are multiplication rules as well as division rules, they follow the same rules, okay? So a negative divided by a positive is always negative. A negative divided by a negative is always positive, okay? So multiplication and division follow the same type of rules. So let's go ahead and do all these multiplication ones first. So here, when you see a parentheses up against parentheses, that means these are multiplied, okay? So a couple of ways you could write multiplication. You could write like a number, parentheses, and then the number inside, right? So this, for example, means 2 times negative 4. So that's one way to write multiplication. Another way you'll see is parentheses up against parentheses. So you might see 2 in parentheses up against another parentheses like this. So these are equal. These mean the same thing. They both mean 2 times negative 4. Another way you might see it is with a dot, right? So you might see like negative 4 and then a dot and then 2, right? So that means 2 times negative 4 again, right? And again, you could switch the order. That's allowed. You also might see like parentheses with a dot in the middle, right? So you might see like negative 4 in parentheses with a dot 2. That's just the same thing. Okay, so just keep that. These are all like the same different ways of just writing the same idea. So you're going to see in the rest of this course, you're going to see multiplication expressed in all these various different ways. Just kind of know that that's what we're going to be using. We will not be using anything like this. So 2 times negative 4 like this with an X for multiplication. Okay, you're not going to be seeing that pretty much at all for the rest of this course. So I would suggest not using an X for multiplication. Usually the X is reserved for the variable, for independent variables. So try not to use X for multiplication, basically for the rest of your life. Okay, so when I see negative 5, this is negative 5 times negative 5. Well, I know the answer is going to be positive because a negative times a negative is positive. So this is going to be positive. 5 times 5, that's 25. Okay, cool. What about this one? This is a negative times a positive. Well, negative times positive, that's negative, okay? So that's going to be negative 25. Okay. A positive times a negative, that's the same idea as a negative times positive, okay? That's going to be a negative. In multiplication, you could switch the order. It gives you the same thing. So this gives you negative 200, for example, okay? I want you to do the rest of the multiplication ones on your own. So try this one on your own and try this one on your own. Okay. Now, there's a lot of different rules for the adding and subtracting stuff, but the main thing I want you to keep in mind is when it comes to adding or subtract, you might see like a negative plus a negative, right? And you might see like you might see a double negative, like you might see like, see how this one has 5 minus negative. So if you see a minus negative like that, you want to make that a plus. So this is the same as saying 5 plus 5, okay? So if you have minus a negative number, that's the same as just saying that number 2, okay? So minus negative 2 is the same as just positive 2. So that's one rule to keep in mind, okay? If two things are the same sign, I'm going to actually erase this here. So if two things are the same sign, you add them. So same sign, add. Same sign, you add those. Okay. If they're different signs, you subtract those. Okay. And when they're different sign, and you always take the sign of whatever you have more of. So your answer will be the sign of whatever you have more of. Take the sign of what you have more of. So if you have more negatives, and you add or subtract, you have more negatives, the answer will be negative. But you have more of. Okay, so if you have more positives, your answer will be positive. If you have more negatives, the answer is negative. Okay, so adding and subtracting got a lot of different rules here. So, but here are some of the main ones. If you see a minus negative, that's the same as a plus. Okay, and maybe I won't put a bullet point here. So that's one rule. Another rule: if they're the same sign, you add them together. If they're different signs, you subtract them. But you always take the sign of whatever you have more of. So if you have more positives, it'll end up being positive. If you have more negatives, being negative. In this one's case, they're both positive. So we know my answer is going to be positive because I have more positives. 5 plus 5, that's 10. Easy. Okay. 5 plus 5, easy. All right. Now this one, this is a negative 5 and then another negative 5. Okay. So negative 5 minus 5 is the same as saying a negative 5. So they're both negative. Oh, they're the same sign. So we add them together. And we take the sign of whatever we have more of. Well, since they're all negative, we take the sign of negative. In other words, it's like you owe me $5 and you owe your friend $5. Well, you would say you owe $10, correct? Here, it's like you owe me $20, but you have 10 in your pocket, right? You can see they're different signs. So different signs, you subtract them. 20 minus 10, that's 10. And you take the sign of whatever you have more of. So in this case, I have more negatives. So that's going to be negative. This problem here is the same as the last one, right? This is a positive 10, but this is a negative 20. So we have more negatives, and they're different signs, so we subtract them. What about this one? Well, in this one, they're different signs again, so we subtract them, but we take the sign of whatever we have more of. So in this case, we have more positives, because that 20, we have 20 positives, right? In this one, they're both negative, right? A minus sign is the same as a negative sign. So they're both negative. They're the same sign, so we add them together. So that's 30. And you take the sign of whatever you have more of. In this case, they're all negative, so we know it'll be negative. Here, this minus negative 20, that's same as saying plus 20. So I could rewrite this problem as 10 plus 20. Well, that's 30. Okay. Now with these adding and subtracting rules, I know they're tricky, but as you keep on going through the class and keep on practicing them, they'll become kind of just intuitive. Okay. All right. Are we on the last page already? Cool. Tim is excited because he thinks he finally got a higher score on his math test than his younger sister, Leela. Tim scored 41 out of 50 on his math test, and Leela scored 21 out of 25 on her most recent math test. Tim thinks that because he got more questions correct, then he got a better score. Explain to Tim in your own words why Leela's score is actually better than his. You must convert both scores into fractions with 100 as denominators so you can think in terms of percentages. Okay. So let's look at Tim's score. So I'm going to put T here for Tim. And his score is 41 out of 50. Okay. So what is that percentage? Well, what we can do is we could change that into it says turn to a fraction with 100 as the denominator. So I'm going to change it to a fraction with 100 as the denominator. So in order to change the denominator, we're multiplying by something. So here we went from 50 to 100. So that means we had to multiply by 2 to get to 100. 50 times 2 gives you 100. So that means I need to multiply the top by 2 as well, and that'll give me 82 out of 100. As a percentage, 82 out of 100, that's 82%. Okay. So he got 82% on his test. Not a bad score. But let's look at Leela's. So Leela, she got 21 out of 25. Now I want to change her fraction to a fraction with 100 in the denominator again. So 25 times what gives me 100? Well, 25 times 4 gives me 100. To keep the fraction equal, I multiply the top by 4 as well. 21 times 4, that's 84. So Leela got 84% on her test. Okay. So then you would want to explain now why Tim's score is not as good as Leela's. So even though he got 41 questions right, but his test was out of 50. Leela got only 21 questions right, but it was out of 25. Okay. So, but you want to explain that although Tim got more questions right, the percentage of questions right that he got is less than the percentage that Leela got. Okay. So go ahead and pause that and give that explanation in your own words. 5a. Show how the greatest common factor of the numbers 10 and 15 can be used to reduce the fraction 10 over 15. So for 10 and 15, the greatest common factor, the GCF for 10 and 15 is 5, because I can divide both of these numbers by 5, and 5 is the largest number, the greatest number, that you could divide them both by. So in order to reduce this fraction, you divide them both by the greatest common factor, which in our case is 5. And that gives you a reduced fraction of 2 out of 3. So 10 over 15 is equal to 2 out of 3. Okay. Use the least common denominator of 10 and 15 to solve 2 over 10 plus 7 out of 15. So 2 over 10 plus 7 out of 15. So hopefully you remember how to add fractions, but basically when you add fractions, you need a common denominator. Okay, you need a common denominator. Now in our case, the common denominator between tenths and 15ths, we're looking for a number that 10 goes into and also 15 goes into. If you want, you can list out their multiples. So the multiples of 10 are 10, 20, 30, 40. All right, I'll stop there my list here, but I could go farther if I need to. For 15, my factors are 15, then 30. Oh, I could stop there because once I see a common multiple, that's going to be my common denominator. Okay. So I see they have one in common. It's 30. So I change both of my fractions into 30ths. So I change the first fraction into 30ths. And also I'm going to change that second fraction into 30ths as well. So 10 times what gives me 30? Well, 10 times 3 gives me 30. So that means I multiply the top, the numerator, by 3 as well. And that gives me 6 out of 30. That's equal to 2 out of 10, but now it has a denominator of 30. Okay. Make sure you're multiplying both numerator and denominator by the same number to get an equal fraction. Here, 15 times what gives me 30? Well, 15 times 2. So that means I need to multiply the numerator by 2 as well. Now that they have the same denominator, I can add them together easily. The denominator does not add, only the numerators do. So 6 plus 14 is 20. So it'll be 20 out of 30, 20 30ths. Okay. I might want to reduce that fraction if I can. So 20 30ths, I could reduce that. I could divide, what can I divide both top and bottom by? Well, I can divide them both by 10. So I'm going to divide them both by 10, and that'll give me 2/3. So now I have the answer in a reduced form, 2/3. Okay, I hope that made sense. I hope you're able to follow along and not get lost. And I hope you're able to write those explanations I asked you to write and do those problems I asked you to do. Okay, well with that, take care, and I'll see you guys next time.